Our last presentation is about glass to concrete pedestrian bridge, and it's presented by Cas Maertens. Cas is a PhD researcher at the Ghent University, and he is investigating structural applications of adhesive bonding between glass and concrete. His research explores the potential of hybrid glass to concrete structures in construction. As part of his work, he contributed to the design and realization of a first full-scale hybrid glass to concrete pedestrian bridge, demonstrating the feasibility of adhesive bonding in structural applications.
Thank you, Miriam. Good afternoon, everyone. Thank you for being here. So today I would like to present to you our hybrid glass-to-concrete pedestrian bridge and how we made it. So first of all, I would like to introduce our research project. So it's called the Glass-to-Concrete Research Project, and it's a collaboration between three partners. So Ghent University, Fischer, and then also Vitroplena, which is a Belgian engineering office specialized in structural glass applications. The goal of this research project is to find a way and to assess methods to bond glass to concrete as an alternative to conventional mechanical connections. And also making glass work and activate structurally together with the concrete. So to give you an idea what we already did in this project, we started actually on the left side with some adhesive characterizations, some tensile tests, different conditions, so to assess which adhesives were suitable for glass to concrete bonding. We also did some interface characterization, for example, this double lap shear test where you have the glass pane here and on two concrete blocks, and then we push it through and see what is the resistance and the shear strength of the interface. And then also some real applications on mid-scale, for example, the balustrade test or the beam test, where we have a beam that is externally reinforced with a glass panel on the bottom side. And then, we had some knowledge gains in this first stage of the research project. But the main goal then was to make something to show to a broader audience what was really feasible, what was doable with glass to concrete bonding. And we really wanted to make some showcase, some demonstrator to present at Glasstec last year. And therefore, the design. So first of all, we wanted to make a demonstrator that showcases the potential, so different applications in the design. But next to that, it also it was something that has to be moved. It was made in overlapping in Ghent. It had to be moved to Düsseldorf, where Glasstec was, which induced some limitations in size, dimensions, and weight also. And as a last criteria, it was something that has to stand on its own. We could not fix something to the floor or something. It is quite some challenge to do that. So it had to be self-supporting actually. And then our team it came up with this design of a pedestrian bridge, which consists of two staircases, one here and one there, and then in the middle part, a bridge deck. The total length of the bridge is 6 meters, and here the middle part makes a span of 3 meters. Here you can see the different applications that were in the design. So first, here is the staircase, which has a concrete steps, and it's fully bonded here on the sides, only on this side to the glass panel. And the glass side panel, is fully supporting this concrete steps. So not only the self-weight of it, but also the weight from people walking on it. So it's not connected on this line, but also everything goes through the glass. Then we have the middle part, so we call it the hybrid glass to concrete floor panel, and it's actually a kind of a sandwich panel with a concrete core with openings or not, and then on the top and at the bottom there is a glass plate bonded to it, so it's working together as a composite. Then at both sides here, you can see there is an integrated T-shaped beam with a concrete flange and a glass web, also working in bending to make the span. And lastly, we also have these glass balustrades, which are bonded here to the side of the hybrid panel. For materials, so we have the glass panels, as they have a structural role. We used thermally toughened glass, also laminated. Here in this case, we mostly used 10-10.4 with a structural interlayer. For the concrete, we used steel fiber reinforced concrete because when you bond glass to concrete, we have two brittle materials. It could be potentially dangerous when we have brittle failure. By using steel fibers, we have a more ductile behavior when concrete fails, ensuring more safety. So because, I said it earlier, we have to make a self-supporting structure, and it also had to be movable. We cannot fix anything to a floor. We also make this. We designed this steel frame. So it consists of a middle part where the middle bridge deck is resting on 2 points, and then 2 side frames for the staircases. Can be it slides over the middle part and can then be fixed and aligned in place. We also did some simulations and calculations. There was already a presentation by my colleague Bert van Lanker this afternoon. So if you're interested in the numerical part and simulation part, you definitely have to read his paper here for GPD also. Then from design to production. So I'll go briefly through the production process. So we firstly started with casting the concrete slab with the openings, and to make the openings we actually used some XPS insulation plates, which we cut into the shapes here and then mounted it on the formwork. And after that, we made this. We demolded it and placed it vertically. Why vertically? Because of the bonding process. We used a 2-component epoxy, which was very, very liquid. And because it was very liquid, we could use that property to use it for bonding. To be more clear, here you can see the shapes. We actually sealed it here on the red lines, sealed all the edges on the outer side, but also on the insides with we call it a spacer tape. And it was also transparent to make sure when we pour it in from the top, it can just fill up from bottom to top for the full height of the panel. And this is then the result after bonding, so you can really see that the tape and the transparent epoxy, it's one visual element here. Then at the bottom side of this hybrid panel, we use a different technique, more with point fixings, not the full area bond. And therefore we used an epoxy that had a higher viscosity to make these dots before placing on the glass plate. And as a last step here, you see we have the slot already made for the T-shaped beam, for the fin, the glass fin that comes in. And as you can see here, we just placed the glass in the slot and then filled the void with epoxy and let it cure. For the staircases, we used kind of a similar technique as the full area bond of the panel. So here you can see this line is fully bonded. We firstly taped it off, so sealed it with the transparent spacer tape, and then placing the glass against it, and then we could fill it from the inside. As you can see here, it fills up from top to bottom. So these are all different compartments, so we all have to fill it separately. Then it was time to assemble everything in our lab, bring everything together, align everything, so the concrete, made sure it was nicely aligned here. And then the last step was to fix this balustrade glass panel for the middle part, also with the same full area bonding technique with the transparent epoxy. Then we moved it by truck to Düsseldorf, to Glasstec, and in place it looked like this. So we covered the steel frame on the floor. So it was only the slender steel columns here you could see from the structure. And I think it looked quite nice. So this is another picture. So this was how it looked like. So some conclusions, because it was the first actual full-scale glass to concrete model or showcase that we made. there were quite some challenges that occurred during the production process. Really quite a lot, but I will give only 3 of them here. So first one, as you can see, yeah, we're working with quite heavy and big elements, and on top of that, we're also bonding a very brittle material to it, so the glass. And because of the bonding techniques, we also have to rotate it quite a lot, put it upwards and then laying it down to make sure, for example, to fill it with epoxy here for the fins, then also placing it on the frame. So it was quite a lot of handling. And in this case, we only use these ropes to lift it. But we think in future it would be nice to have some openings where you could screw in some anchors, for example, on the sides that you could easily rotate and lift the whole structure. Then here, yeah, tolerance is also a very important point because we have a lot of elements coming together: the concrete, the glass, the adhesive layer in between, but then also the steel frame. Yeah, when assembling everything, it was not quite directly, immediately right in place, so we have to adjust a bit. So in future, there are 2 strategies actually. So either way, we go, yeah, let more tolerances, allow more tolerances. The deviations from the theoretical design allow them, or we search for ways to more control the thickness, for example, of the concrete or the adhesive layer. So we are more close to the designed dimensions. And then the last point, so as you can see here, this was the hybrid panel, and the darker area is where the adhesive comes in contact with the concrete. And as you can see, it becomes very dark because this is the normal concrete, which had as a result, if we would yeah, just tape off this side on the dry concrete and then pour in the adhesive, sorry, we would have on the inside here a darker color, and on the edges just this lighter color, which would not be favorable. As a result, what we needed to do was firstly coat the full area, the full bonded area, with adhesive. So we got already this darker color, and then placing the transparent spacer tape. So we would have an uniform look to that. So I would like to thank everyone involved in this project to make this a success. So Ghent University and all the whole team, also Vitroplena and Fischer. We're very happy to have realized this. Thank you.